Welcome to the UGC EPG Pathshala lecture series in computer science. In this series of lectures, we have been looking at database management system. For today's session, I will be discussing on data mining. This data mining is one of the advanced concept in databases. Already we have looked into a concept called data warehousing. This will be a continuation from a data warehouse where we have large volume of data. So, data warehouse in turn projects data mining as a very good tool which can extract a lot of hidden information. Some of the learning objectives for this session include: first we will try to understand the objectives of data mining, then we will try to elicit on why we need a data mining, then we will try distinguishing between the normal processing, database processing and data mining processing, and finally we will try to detail all the individual tasks of data mining. So, this session will be a preliminary discussion on data mining tasks. Before we actually understand on data mining, let me give you a simple example of this data mining. Applying data mining in the retail industry. Say for example, if I am a retail business person, then customers are the most important people for my business. Then in that case, I can fix up the value of, or I can look at the cost and making out a minimum profit of the business, or I can produce coupons on purchase of say 1000 rupees and more, which thereby I try to attract more of the customers. So, this is one of the strategy that I maintain so that I attract more of the customers. So, this is on product pricing. Then I have another trend which is called purchase trends, based on which I can say if I purchase this and this together, say product 1 and product 2 together, then that might lead to a lower cost, or a combination would result in slightly less than the actual cost. So, I might give discounts for purchase of one or more items. And third is based on the customer segmentation. Say for example, I find different customers who approach my business or who are the customers of my business, then I will try segmenting those customers according to a state. And lastly, I have customers who are effective of promotions and advertisements. Say how do I attract? By basically projecting more of promotions and advertisements. So, these are some of the very good techniques that I can follow which are based out of data mining. So, this gives you a gist of idea of what data mining is. With that as a base, we will try understanding on data mining. Data mining, we sometimes call it as knowledge discovery in databases, which actually leads to the extraction of interesting, that is non-trivial, implicit, previously unknown and potentially useful. I repeat, non-trivial, implicit, previously unknown. So, something that is non-known to us in prior and potentially useful. What data is potentially useful to us, we can select on that. So, extraction of these interesting information or patterns from data in large databases. So, that leads to a data mining scenario. Not only that, if you look at this knowledge discovery process, knowledge discovery in data mining or knowledge discovery in databases actually flows through extraction of this knowledge. If you look at the complete hierarchy of the file system, it started with raw facts, then data, then information, then knowledge, then wisdom. So, we are really now at the knowledge phase. So far what we have been looking at is either a data or an information. Now, we wanted more of knowledge to be extracted. So, knowledge extraction plays a vital role. Not only that, we can analyze on the patterns, or we can do a data analysis or pattern analysis, thereby we can extract a lot of knowledge. Not only that, we can do an archaeology of data, and finally, the entire extraction of knowledge is done basically for business intelligence. So, these are the potential uses by where this data mining might be helpful. Looking at in depth of this definition of data mining, I have told you data mining is nothing but a non-trivial, implicit, previously unknown and potentially useful information. But then there are some hidden values, hidden information that are available in the databases. So, we may have to find out those hidden informations. So, that is the preliminary intention with which we start doing data mining. When you have voluminous amount of data, then finding appropriate data values from the hidden data becomes a key point. So, that is the intention of this data mining, and fit data to a model. And similarly, we have multiple terms which are in connection with this key concept called data mining. We have similar terms like exploratory data analysis. This data mining can also be called as exploratory data analysis or data driven discovery or detective learning. Already we have looked into detective databases, but then we produce more of machine learning activities and we have lot of detective learning. With what as a motivation this data mining has started? So, motivation behind we use of data mining. We come across a common problem of extraction of data. So, we say it as data explosion problem, where there are automated data collection tools and mature database technology led to tremendous amount of data stored in databases. As I have already said, it is not actually, data mining is not actually trying to apply to a database. Instead, this data mining is applied to a vast amount of data, so which is more of a data warehouse type. So, data warehouses and other information repositories we try to use this data mining with. So, that is the actual data explosion problem, but then we are drowning in data but starving for knowledge. So, what we have is vast quantity of data, but initially we tried to convert all the data into information which was part of data warehouse, but then we try extracting lot of knowledge from it. We either do a statistics, we either do a clustering, classification, by where we try typically understanding on what as a domain we extract similar kinds of data. So, we are actually starving for data, but what we have in large is we are starving for knowledge, what in large we have is a data. So, the solution to this question would be either a data warehousing or a data mining. So, if you largely look at data warehousing, we have transformed data into information, but with data mining we can convert data to a knowledge. Data warehousing and online analytical processing majorly helps towards building up knowledge and extraction of interesting knowledge like framing up of rules, making it regular, deriving patterns and looking at all the constraints from data in large databases. So, this is the preliminary intention or the motivation with which the concept of data mining has started. Something that pokes our mind, which is why to mine data. Rapid computerization of businesses produce huge amount of data. Everybody in today's world is trying to convert their business into an automated process, thereby they are making it fully computerized. Thereby we have huge volumes of data and we never wanted the data to be replicated in the same form. Say with the database management system, what we have done is we have typed in a SQL statement for which we retrieved a query. After having made it as an automated process, we don't want the same activity to happen. Instead, there are expectations more than how we extract the data. So, how to make best use of data is a growing realization, where the knowledge discovered from data can be used for competitive advantage. So, any knowledge that we tend to discover from the existing data, we use it for a competitive advantage. Thereby we can produce it like a statistic. Say for example, compared to the last year, we have 10% increase in the productivity of the products, say 20% more of sale ratio. So, this 20% hike is not actually derived from the data, but then we are trying to present it in a different form. Let us try to understand why this mining of data is essential from two different perspectives. The first perspective is a commercial viewpoint, where we tend to understand lots of data is being collected and warehoused. Let us say for example, we have web data or we collect information from e-commerce websites, or otherwise we have purchase at department or grocery stores, or we have a list of bank credit card transactions that happen. So if you look at all the collections or the entire collection of these data values, it will be in turn a large collection of data. So computers have become cheaper, and not only that, it has become more powerful than, so we have a competitive pressure of making the computers more strong in comparison. So we have to provide better customized services for an edge. That is, for example, we may have customer relationship management, which needs to have a large volume of extraction of data. So that is from the customer's viewpoint. Not only that, several researchers, several scientists, they have large quantum of data. Say for example, geographical information system, geographical positioning system, remote sensing data. All these are available as feature points, and lot of feature points are available. Instead, how to process with these feature points? So scientific viewpoint gives us a detail of multiple instances, like say data collected and stored at enormous speeds, say several GB of data per hour, from remote sensors on a satellite, from telescopes scanning the skies, microarrays generating gene expression data, scientific simulations generating terabytes of data. So we have crossed this terabytes of data. Today we talk about big data analytics, we talk about internet of everything, where we start discussing on more of data values. So from gigabytes we have started crossing to terabytes, petabytes, exabytes, and so. So when we go for higher volumes, although we should not be proud enough to say that we have large volume of data, at the same time we should be able to effectively process on all this data, for which this data mining might be of much use. So this is not a traditional technique in comparison with the raw data, and data mining helps scientists in way of classifying and segmenting data, and not only that, it can create and formulate new hypotheses. Let us try understanding why this data mining is necessary. This data mining makes use of large data assets. There is a big gap from stored data to knowledge, and the transition won't occur automatically. Many interesting things you want to find cannot be found using database queries. Say for example, if I would have been a very good user of SQL, most of the instances I may not be able to visualize and see. Say for example, find me people likely to buy my products. So likely to buy my products, I may have a list of several products, but then in SQL we may need to highlight what are the products and the product name as stored in the database need to be retrieved. But then with the data mining, since it is voluminous in size, we may have to process it to the next level. And the second type of question that can be answered not with the database, it can be answered with the data, where data mining is, who are likely to respond to my promotion. Here promotion is from the business point of view. Say for example, you would have come across question which have been asking for, have you looked at our branding from TV advertisement or paper advertisement or from friends, referred by friends, and radio. So many things would have appeared, but then these are just categorization of data. So what promotions made me likely to respond, so that I will be more likely able to catch up with that for the next several instances. So having looked at the motivation of data mining, why this data mining is necessary, let us try to understand what is the importance of projecting data mining now. As I have told you, we have crossed terabytes, we started using petabytes of data, and we are still at exabytes of data. So the data is abundant, data is being warehoused, the computing power is being affordable, the competitive pressure is so strong, and data mining tools have become available largely in the market. So that is the reason why we tend to proceed more with the data mining at present. So we will try understanding between what is not data mining and what is data mining. So people who have a greater knowledge in databases might likely to have a doubt in their mind. I have understood databases, it does most of the processing, but what is that special with databases? We will try comparing on that, but we will try at the same time what is not data mining. First we will look at what is not data mining. Say for example, we have a lookup phone number in the phone directory. We have a query a web search engine for information about Amazon. So these are not typically with the data mining, whereas with the data mining we have certain names that are more prevalent in certain countries. Say in India if you take, and particularly in South, Kannan, Sendil and other names are more common names that are used in these, and there can be groups that can group together similar documents written by the search engine according to their context. Say for example, Amazon's rainforest, Amazon.com. So Amazon rainforest is more similar when compared to Amazon.com. So you should not retrieve Amazon rainforest when I am searching for Amazon.com. So this is most likely a product website, and this is more of a forest which is available in the United States of America. So as I have told you, we try comparing between database processing and data mining processing. So as you might know and you might appreciate, with respect to three different categories like query, data and output, with respect to database processing, queries are actually being well defined and we use structured query language for querying purpose. And the data available with the databases are purely operational data. And the output that I receive from a database system would be very precise, that is very accurate, since it is pertaining to a list of data, group of data, and this will be of a form of a subset of a database. Whereas it is not the same when I try shifting to a data mining processing. If I look at a data mining processing where queries are poorly being defined and there is no precise query language that I am trying to talk in terms of data mining. And if I look for a data, it has not been an operational data which I am looking at, so it is not a centralized or conventional data which I am looking for. But then the output seems fuzzy for my entire query, and this will never be a subset of data, or the values that is available in the database need not be replicated or reciprocated in the result. So this need not be a subset of data. Instead, it will be of some other format. It can be of a visualization format. It can be of, say, I can give you a cluster of data, I can give you a classified data, I can give you outliers which are pertaining to the given data. So these are different formats in which I can present my data, which has never been happened with my database processing. Having understood the differentiation between a database processing and a data mining processing, let us try understanding on some of the examples of queries which we differentiate between databases and data mining. See, with respect to database management system, we will present queries something like find all credit applicants with the last name of Smith. So I am projecting and I am trying to fetch all the values which ends with Smith and who are all credit card applicants. So it will try retrieving, checking the condition that the last name should be Smith and he should be a credit card holder. Identify customers who have purchased more than 10,000 rupees in the last month. So by where I am trying to distinguish a specified group of customers, saying that these customers are my valid customer who have purchased more than 10,000 rupees. Find all customers who have purchased milk. So these are typical things that might be available in the database relations, database tables. So I can directly retrieve just by typing in or just by querying with a SQL query language. Whereas this data mining we are talking about is not on the same, where our queries might be reflected something like find all credit applicants who are poor credit risks. So my credit limit seems to be very poor in terms of maintenance. So I am into more of risk category. So how do I retrieve those customers who have their credit cards with poor credit limits? So for which I might use one of the technique called classification techniques in data mining, which we will look at very shortly. Identify customers with similar buying habits. So say for example, I have a strategy by which I generally purchase my things. Say if in case I have got a shirt, then I will go for a pant. If in case I have got a bread, then I will go for jam. So identify those customers who are buying similar patterns, that has to be listed. So similar buying habits need to be clustered together. Find all items which are frequently purchased with milk. Say for example, I try retrieving any number of items which are purchased along with milk. When I buy 500 ml of milk, along with that what are the other items which I am likely to buy. So for which I might use association rules, and these are several or some of the techniques that I am trying to present on top of what database management system could not project. Looking at some of the data mining classification schemes. So till this particular slide we have understood clearly on the motivation with which we have started data mining. Not only that, we in turn made several comparisons with respect to database management systems. So how is database management system different from data mining? So what gives more importance towards, why we give more importance to data mining rather than typically retrieving from a database processing system? Now we will understand more closely into the classification schemes. For exactly retrieving on the different classification schemes, let us try to understand the decisions that we can make by use of data mining. So as I have already told you, data mining is a process which typically is used during business intelligence. So BI is one of the major strength by BI gives one of the major strength by use of this data mining techniques. So what kinds of databases to be mined? It not only understands, it understands on kinds of knowledge to be discovered, kinds of techniques to be utilized, kinds of applications to be adopted. So now that we tend to understand, if at all we are to take a better decision or an effective decision, at the same time you can recall some of the definitions that I gave towards defining a data warehouse. The understanding of data warehouse, we made some properties very clear, and finally we have said all this we tend to do primarily because we wanted to have better decisions to be taken, effective decisions to be taken. So in order to take effective decisions, we may have to understand clearly on the kind of database that we are about to mine. Not only on that, the knowledge that we are supposed to discover, the techniques that we are supposed to utilize, and the application for which I am tending to apply this data mining techniques too. For which, to clearly distinguish and project the classification scheme, we have several data mining tasks, few of which is being described here. Say the data mining tasks are basically being classified into predictive data mining and descriptive data mining. Let us try understanding what these two data mining tasks are. But to look at close on the decisions in data mining, let us try comparing between a mining that is taking place in a database and a mining which is happening in extraction of a knowledge. If you look at databases that is to be mined, databases to be mined are typically relational, transactional, object oriented, object relational, active databases, spatial databases, time series databases, text databases, multimedia databases, heterogeneous databases, legacy databases, World Wide Web databases, etc., like XML sequences. but this is where we tend to discover our knowledge from, but then these are typically in database formats, whereas where can this knowledge be mined? So the knowledge to be mined are basically to be characterized, discriminated, association has to be formed, classified, clustered, trend evaluation. We tend to study on the deviations and outlier analysis, etc. So if you look closely into the knowledge that we are tend to mine, it is not on a particular topic that I am expecting it to make a decision. Rather, I am converting the given data into one specific format from where I can generate knowledges. So these knowledges are multiple integrated functions, and this tend to mine at multiple levels. In this session, we have started discussing about data mining, where I have let you known the very preliminary information about data mining. So we initially started defining what data mining is. Data mining is nothing but a knowledge discovery process which can extract non-trivial, implicit, previously unknown, hidden information from a large corpus of a data. And further, we have started discussing about the importance of data mining towards motivation behind why we require a data mining. And we tried comparing database processing with data mining processing, where we had standard tools which can cover database processing, but then there are tools available, but then covering the entire volume of data mining tasks is typically large in size, and the requirement by itself will vary according to the application. Not only that, we talked more about data mining is more about knowledge discovery in databases. Thank you.